Let's start off with our chapter on polynomials. We need to set a foundation for some vocabulary words. First, I want to talk about monomials. Notice it says monomial. For a monomial, the simplest definition is when you have one term. Now, one term can take several different forms. We could talk about having a simple constant. We could say something like 3. That's considered a monomial. You could have 5x. You could have 7x squared y cubed z. Notice with all three of these examples, you essentially have one term that's listed. If you move into multiple terms, we call those binomials. Example. A binomial is when you have two terms, like 3x plus 2 or 5m minus 3t. Here you see that the terms are separated by either a plus or a minus. Because there are two of them, we call them a binomial. Just like you consider a bicycle has two wheels. In math, if you have two terms, we call those a binomial. One term is a monomial, and the chapter is called polynomials. So poly must mean when you have several terms. Usually it's denoted as 2 or more. Example 3. We could have something called a trinomial. With a trinomial, you'll have, as you might guess, 3 terms, like a tricycle, 3 wheels. So you might say something like x squared plus 5x plus 2. Now notice as we get more complicated and we have multiple terms, these are not the same type animal, same critter, same term. An x squared is very different than just a simple x, which is very different than a simple number, a constant. And so we can have this take several shapes, several forms. I might say something like 5x squared minus 2xy plus 3y squared. Because I have 3 distinguishable terms, that would be considered a trinomial. Anything more than that, we just go to polynomial. Now, before I move on, I want to go back to the idea of what is a monomial and show you examples of things that may or may not be a monomial. Example, if I said 2x over y, this is not a monomial. Even though it looks like there's only one term, it's implied that it has division there. And so this would become known as a rational expression. It's not a monomial because I don't have all the variables up top. However, you may be tricked into seeing something like this, a squared bc over 7. Now, by the definition that I just gave you, you may be thinking, well, no, that can't be a monomial either. But when I talked about this previous problem or this previous example here, I said it was a rational expression because it had a variable on the top in the numerator and a variable in the denominator. With this example, I can actually pull out the 1/7 as a coefficient and then say a squared bc. This is an example of a monomial. There's only one type critter there, there's only one term. It just so happens that the coefficient is a fraction, which is very possible and very legal. Over here I could change these. These are monomials as we previously stated. I could call this 7/10 x squared y cubed z, and that's still considered a monomial because all the variables are written as what we can call a one-liner, and they're all considered in the numerator. Monomial. No pluses or minuses. Division's not allowed if you're dividing fractions. If there is a division bar or a fraction bar, if you can pull the number out, like 1/7 here, then it's considered a monomial because the variables are all numerators and the coefficient was just a fraction. That's our introduction for the vocabulary on the chapter of polynomials. Monomial means one term. Binomial means 2. Trinomial means 3.